Hello everyone, welcome to Chemistry by ANR. This is conversions in organic reactions. The first conversion that we are seeing is phenol to picric acid. To convert phenol to picric acid, you can just give concentrated HNO3 and you can get picric acid. But you need not give concentrated H2SO4 also. Now, this yield of picric acid to be good, you can do it stepwise, and this is considered to be better. That first you give concentrated H2SO4, convert it to the sulfonic acid, and then you give concentrated HNO3 and then you will get picric acid, which has a very good yield. So if picric acid needs to be formed, you can just give concentrated HNO3 because phenol is activated in nature. Now, if you give dilute HNO3, what will happen to phenol? If you give dilute HNO3, suppose you are writing that I am giving dilute HNO3. So here you will get para product as the major product. So here there is OH, here there is NO2. So this is the major product. The ortho will be also obtained in minor amount, and you can separate them by steam distillation method. This is the minor product. So next one, benzene to phenol. Now these all conversions, see, conversions are many in number, but these are the common concepts which come in most of the exam and of course in CBSE board exam. So benzene to phenol, first you give oleum H2S2O7, convert it to benzene sulfonic acid, and then you give NaOH and acidify H plus and H2O and you will get phenol. So next is nitrobenzene to phenol. Nitrobenzene, you reduce it. This is the reduction process, reduction of nitrobenzene to aniline. So use SnHCl or you can use Fe plus HCl and then undergo diazotization reaction, giving aqueous NaNO2 plus dilute HCl 0 to 5 degrees Celsius, forming benzene diazonium chloride, and you give warm water in order to obtain phenol. So benzene diazonium halide is an important intermediate to give you many products. So cumene to phenol. Cumene is isopropyl benzene. So this is cumene. You give oxygen and you get cumene hydroperoxide. And then you do H plus H2O hydrolysis, you will get phenol. Remember here there is one important side product which is acetone. So if this is not asked, because this is only conversion, you need not write acetone. Phenol to benzoquinone. Now this is an oxidized product. So phenol undergoes oxidation. You give K2Cr2O7 plus H2SO4 and you will get benzoquinone. Now phenol to para-nitrophenol. This is the one which I was telling you. Give dilute HNO3. You will get para-nitrophenol. This is the major amount and you separate. Along with this you will obviously get a minor amount of ortho product. You separate it by steam distillation as the ortho product is more steam volatile. This is the other concept. Now in conversions you need not write this is more steam volatile. Just write separation by steam distillation. Now benzene to benzaldehyde. You can convert benzene to first toluene and then convert toluene to benzaldehyde using Itard reaction. So what you can do, you give CH3Cl anhydrous AlCl3. This is Friedel-Crafts alkylation reaction and then you get toluene and then you do Itard reaction giving CrO2Cl2 in presence of CS2 followed by H3O plus. Or you can also do it by this Gattermann-Koch reaction, that CO plus HCl in presence of anhydrous AlCl3 or CuCl. This is a direct method. Next, benzene to diphenyl ketone. Diphenyl ketone is this thing. So it's benzophenone. So what will happen? Benzene plus this C6H5COCl. C6H5COCl. This is benzylation reaction. So you use anhydrous AlCl3 as the Lewis acid catalyst, and then you get the product. Bromobenzene to benzoic acid. Now this bromobenzene, always remember that you are increasing the number of carbon atom by 1 unit. So if it is aryl halide, if it is alkyl halide, you try out the Grignard formation. So you do Mg dry ether and you are getting Grignard, and you give CO2 in order to increase the number of carbon atom. So CO2H3O plus, and you will get benzoic acid. Acetophenone to benzoic acid. Now here, like acetophenone to benzoic acid, styrene to benzoic acid, also the same thing happens. Why? What is styrene? Styrene means this thing, benzene ring, CH double bonded CH2. This is styrene. So same way, acetophenone, this is acetophenone, COCH3. You give KMNO4 KOH, alkaline medium, heat, and number 2 H3O plus. Some of the students says that, ma'am, can we write it stepwise? Yes, you can always write it stepwise. If you write it stepwise, then you have to write COOK and then write H3O plus and give COOH. Otherwise, you can write it together giving 1 and 2 conditions. Next, benzene to parachloroacetophenone. So here, if you first go to formation of acetophenone, you will not get chloro in the para position because COCH3 is deactivating group. So first you have to introduce Cl, and that you can do by Cl2 anhydrous AlCl3. You will get chlorobenzene, and then you give CH3COCl anhydrous AlCl3. Friedel-Crafts acylation. This is Friedel-Crafts acylation, and you will get COCH3 in the para position as the major product because Cl is ortho-para directing. It is activating group. Benzene to diphenyl. So here you know that diphenyl formation, you can get it from Fittig reaction, but for that you need halo. So over benzene you can do chlorination, Cl2 anhydrous AlCl3. So this is an example of aromatic electrophilic substitution reaction, and you will get Cl2. And then you give 2Na in presence of dry ether. This is your Fittig reaction, and you will get diphenyl. Next, tertiary butyl bromide to isobutyl bromide. This is your tertiary butyl bromide. See, there are 4 carbon atoms, so it is but system, and this carbon is directly linked to 1, 2 and 3. So this is 3 degree. So this is tertiary butyl bromide. Isobutyl bromide, this is your iso linkage, and here it is a but system, so CH2Br. How can you do it? So here you have to first do elimination reaction giving alcoholic KOH and heat. So this is your beta elimination reaction. When you do so, from this is alpha position Br, all the beta are same. So from here H is eliminated, and you get a double bond between alpha and the beta by the elimination of HBr. So you get a double bond, and then see the position of the Br. The Br is to be attached to the carbon having more number of hydrogen atom. So follow anti-Markovnikov manner. For anti-Markovnikov, it is only HBr that is being used. So do not use any other halide over here. So HBr peroxide, you will get the product. Benzene to phenyl isocyanide. Now this is not same as cyanobenzene. Cyanobenzene is CN, but isocyanide means NC. So this you always remember, this is a reaction which is you are getting NC. And you know it is a name reaction. We have done it. So here what is happening is you are getting benzene to nitrobenzene, nitration. Now, so for this you need nitrating mixture. You just cannot give concentrated HNO3. Along with that you need concentrated H2SO4. And then because if you don't give H2SO4 you will not get the electrophile, which is NO2 plus. Then you do reduction using SnHCl, and or you can also use FeHCl. If you are used to writing FeHCl, then do that, get aniline, and then you do carbylamine reaction. So this is CHCl3 and alcoholic KOH heat. You will get isocyanide. Next, 2-bromopropane to 1-bromopropane. These types of questions are also very common, where you see the position of the Br changes, or maybe the position of the double bond is only changing. So here 2-bromopropane, first do beta elimination. So this is alpha position, Br will go. From beta position, H will go, minus HBr, and you get propene. Now see where the bromo needs to come. It needs to come in carbon number 1, which is less substituted. So follow anti-Markovnikov, HBr peroxide. Chlorobenzene to para-nitrophenol. Now nitro is to be introduced, OH is also to be introduced. Which one to be introduced first? So obviously you have to first introduce something that will help you to bring in the para position the other group. So here you see chlorobenzene is orthopara directing, right? So when you do nitration, concentrated HNO3 and concentrated H2SO4, you will get NO2. Now some of the student thinks it that, okay, why can't I bring OH first by doing Dow's process, and OH is orthopara directing, and then I will give dilute HNO3 and I will get nitro in the para position. So please understand one thing, Dow's process is not a very favorable process. You need very high temperature, 623 Kelvin, 300 atmospheric pressure. Moreover, chlorobenzene is less reactive. So for that reason, you need that drastic condition. Now, if you do nitration, which is an electron, withdrawing group, you are increasing the reactivity of the chlorobenzene. And so you need a less drastic condition. 15% NaOH, 433 Kelvin, then dilute HCl, and then you will get OH coming, that is replacing Cl, you will get OH coming in the para position. Just to increase the reactivity of chlorobenzene, you can first introduce nitro, electron withdrawing group, and increase the reactivity. Okay, 2-chloropropane to propan, 1-ol. So 2 position there is chloro, but you need in 1 position OH. So what to do? First you give alcoholic KOH heat, beta elimination reaction, and Cl and H is removed and you get a double bond over here. Now in order to get OH, you cannot do directly. Some of the students say, okay ma'am, anti-Markovnikov manner, I can just do hydroboration and then I can get. Yes, you can get it also by doing anti-Markovnikov manner of addition of HOH. Otherwise you can do it HBr peroxide, get Br over here, and simply substitution reaction, aqueous KOH and heat, and then you get the product. Nitrobenzene to chlorobenzene. Like see here again I told you one alternative method, that means from the propene to propanol. There are many alternative methods, but go for the one which is where the reagents are easily available. Go for the one where the number of steps also is less. Nitrobenzene to chlorobenzene. So here again, nitrobenzene you can do reduction in order to get aniline. And then you do diazotization reaction, give the condition complete, aqueous NaNO2 plus dilute HCl 0 to 5 degrees Celsius, and you will get benzene diazonium chloride. This you do Sandmeyer or you do Gattermann and you will get chlorobenzene. CuCl, HCl you can give, you'll get chlorobenzene. Now benzene to benzyl alcohol. Benzyl alcohol, wherever you have to bring OH, you try to bring it from halo. And then you can think that if I can get halo, I can do substitution giving aqueous KOH and heat, and then I can get that OH. To get the halo in benzene, you have to give any substituent. So you do Friedel-Crafts alkylation, and then you get toluene. You are doing Friedel-Crafts alkylation, CH3Cl, anhydrous AlCl3, and you are getting toluene, methyl benzene. And to this system, you are doing free radical halogenation, and you will get CH2Cl. Now here you cannot give anhydrous AlCl3, otherwise you will get orthopara product. So this is the benzylic position, CH3. This is the benzylic position, and you do free radical halogenation, and then you will get CH2Cl. Now to substitute this Cl by OH, give aqueous KOH and heat. Next, I told you shifting the position of the double bond and all this thing. So 1 bromopropane to 2 bromopropane. This is shifting the position of Br. You give alcoholic KOH heat, you will get propene, and then you do HBr. Here it is not peroxide. Why? Because it was previously when you had to bring it to one position, then you had given peroxide. You have done just the opposite in the previous case. So here what you are doing, to 1 bromopropane, you are carrying out beta elimination followed by HBr, Markovnikov way of addition of HBr. Next, butene to N-butyl iodide. Iodide, fluoride, try to go to the halogen exchange reaction. So this is Finkelstein reaction, but for Finkelstein, you have to obtain the chloro or bromo product. So in order to obtain that, in the one position, you cannot use HCl, because HCl will not give you anti-Markovnikov manner because of the high bond enthalpy of H and Cl. So you do HBr peroxide. In the first position, you are getting bromo because it is anti-Markovnikov. And then you do Finkelstein, NaI dry acetone. You give NaI dry acetone, and you get in place of Br, you will get I. Next, benzyl alcohol to 2-phenyl ethanoic acid. Please be careful while writing the structure of 2-phenyl ethanoic acid. First, write ethanoic acid, and in 2 position give one phenyl ring. So for this, what to do? What are the changes? Here OH is there, here COOH is there. So there is one carbon atom extra. Often when you need COOH, follow the hydrolysis of CN. Okay, so try to obtain CN and then do acidic hydrolysis, and then you will get COOH. So in order to obtain CN, you need to convert it to Cl giving SOCl2, and then give alcoholic KCN. When you are giving alcoholic KCN, then you are getting CH2CN. You have increased the number of carbon atom and just go to H plus H2O, or you can directly write H3O plus also. Then CN will get converted to COOH. Next, propene to 1 fluoro. Fluoro, when you are writing, again think of halogen exchange, Schwarz reaction. Now see the position, one position. So obviously you will convert it to Br by anti-Markovnikov. So HBr peroxide, you are getting Br in the terminal position, and then give AgF, easy to remember, AgF heat, and then you will get the fluoro compound. Propanone to 2-methyl propan 2-ol. Propanone is a ketone. Now this is an alcohol. You should learn how to think. This is how many degree alcohol? See, it is 3 degree alcohol. So with Grignard reagent, if you remember that if you add Grignard to formaldehyde HCHO, you will get 1 degree alcohol. Then you add it to RCHO, you will get 2 degree alcohol. And with ketone, you will get 3 degree alcohol. So obviously you need Grignard. In this propanone, you already have 3 carbon atom. Now in the product, you need 4 carbon atom. 4 carbon atom means there is a methyl getting extra. So obviously the Grignard will be CH3MgBr, dry ether medium. So you got Grignard, and then hydrolysis H2OH plus, here OH, here H and here OH, and you get the product. This is how to think. Now methanol, HCHO to propanol, alcohol. So I told you just now that in order to obtain alcohol from HCHO, then you will get only 1 degree alcohol. From RCHO, using Grignard, of course, you will get 2 degree alcohol. So here again, this is methanol and you are getting a 1 degree alcohol. So 1 degree alcohol, this CH2OH you got from methanol. There are extra 2 carbon. This 2 carbon came from the Grignard. So Grignard will be CH3, CH2, MgBr or MgCl, whichever you are taking, dry ether medium and then H3O plus. Then you will get this 1 degree alcohol. Phenol to anisole. This is anisole, OCH3, methoxybenzene is anisole. What you can do is give NaOH and get sodium phenoxide, and then give CH3Br, you will get OCH3. Why? This is Williamson synthesis. See, this is sodium phenoxide. So this is acting as a nucleophile, now attacking over C, and then Br is leaving. So this is the Williamson synthesis of formation of ether. Now here you are converting it to sodium phenoxide and then CH3Br. Propan-2-ol to 2-methyl propan-2-ol. Again, here you can see that it is alcohol, but the number of carbon atom has increased and the final alcohol is a 3 degree. So try to convert it to a ketone. If you convert it to a ketone and give 1 carbon atom wala Grignard, then you can get this. So it is propan-2-ol. Do controlled oxidation. Give PCC. You will get the ketone. And then, you know, PCC, pyridinium chlorochromate, it is used for controlled oxidation. And then you give CH3, MgBr, H2O and you get the product. Phenol to aspirin, convert it to salicylic acid. This is salicylic acid and you convert it by coal-based reaction. How you can do? First NaOH, convert it to ONA to increase the nucleophilicity, and then give CO2 and H+. You will get salicylic acid, and then you do acetylation reaction. So you will get acetyl salicylic acid, which is aspirin, which is used as an antipyretic, which reduces fever, and analgesic, which reduces pain. Now ethanamine to methanamine. Ethanamine was having 2 carbon atom. Methanamine is now having 1 carbon atom. Always remember, if you need to decrease the number of carbon atom and the compound has NH2, somewhere you need to get into the path of Hofmann bromamide. So here, how to go to Hofmann bromamide? Because Hofmann bromamide requires CONH2. The safest path to go is via COOH. So convert this NH2 to OH. How? Because this is aliphatic primary amine. If you do HNO2, or if you write also aqueous NaNO2 plus dilute HCl 0 to 5 degrees Celsius, then you will get N2 plus Cl minus, which is unstable, and you will get alcohol as the final product. Now this alcohol is undergoing oxidation. That's why you are using CrO3H2SO4 or any other strong oxidizing agent. If you do, you need strong. Why strong? Such that the reaction doesn't stop in the aldehyde stage. So you are getting from 1 degree alcohol, you are getting carboxylic acid. Now to this carboxylic acid, you give NH3 and heat, and you will get CONH2. If you want, you can go from COCl also, but there you will increase the number of carbon atom. So NH3 heat, you are getting CONH2, and this is your Hofmann bromamide, where you are giving Br2 KOH. Now, benzene to meta-nitroacetophenone, meta position. So first you do acetylation reaction, giving acetic anhydride, anhydrous AlCl3, and get it acetophenone. This is your acetophenone, COCH3, and then you do nitration because COCH3 is a deactivating group. Benzoic acid to benzaldehyde. Convert benzoic acid to benzoyl chloride, that is SOCl2, you give COCl, and then you do Rosenmund reduction. This is your Rosenmund reduction, H2, PDBSO4 or sulfur quinoline, and then you will get benzaldehyde. So when you need, suppose there was the conversion benzene to benzaldehyde, you converted it to toluene and then you have done ETAD, or you can directly do by Gattermann-Koch. But here again, you can take the help of Rosenmund. You convert it to COC6H5COCl and then do Rosenmund. Now 3-methyl aniline to 3-nitrotoluene. Now see the changes. You need nitro and toluene means the CH3 will be there. So actually you are converting this NH2 to NO2. Now whenever you start with NH2 and you want to get say H over there, you want to get OH over there, you want to get NO2 over there, or maybe any halo compound over there, go via diazotization, which is an important intermediate. So do aqueous NaNO2 dilute HCl 0 to 5 degrees Celsius and get N2 plus Cl minus. Over there you give HbF4 NaNO2 Cu heat and you will get a nitro in place of N2 plus and Cl minus. Now aniline to 1,3,5-tribromoaniline. Again, tribromo, whenever you see 3 bromine are there in aniline, bromine water, give bromine water. Same thing happens in phenol. If 3-bromine 1,3,5 position is required, bromine water. So bromine water you give and you get 1,3,5 say aniline you are getting. Now you need bromoaniline, tribromoaniline. Okay, so you are getting you are getting 2,4,6 tribromoaniline, not 1,3,5, 2,4,6 tribromoaniline when you are giving bromine water. Now this one position, what happens? You need H over there. So for that reason, you can again undergo diazotization reaction, aqueous NaNO2 dilute HCl 0 to 5 degrees Celsius, and then again give H3PO2 H2O. In place of N2 plus Cl minus, H will come and this is the product. So next, ethanoic acid to methanamine. Ethanoic acid, CH3COOH, and see methanamine, CH3NH2. Again the same thing. If you need NH2, try to go via this thing Hoffman bromamide and try to get a CONH2. So you started with COOH, converted to COCl, giving SOCl2, and then excess of NH3 and you will get CONH2, and then you do Hoffman bromamide, bromine KOH. So methanol to ethanoic acid. You have 1 carbon atom alcohol. Now you need 2 carbon atom acid. What to do? I told you that if you have to increase the number of carbon atom, either go by Grignard or go by CN. So if you need COOH, then you can do the hydrolysis of CN and get this COOH. So over alcohol, you can give SOCl2 and you get CH3Cl, and then you give alcoholic KCN. Do not give alcoholic KCN over alcohol. People make this mistake. Convert it to RCl by giving SOCl2. Then give alcoholic KCN. You will get CH3CN, and then you go to acidic hydrolysis. You will get CH3COOH. So these are the top 35 probable conversions for your CBSE board exam or your any of the competitive exam. See you in the next video. Bye all of you.